right, we're screen sharing, we're PowerPointing. It's going to be a good day. Good. Cool. Okay, let's go ahead and get started once again. So as always, let's start out class with a quick check-in on how things are going in your process. Has anybody had a chance to line up for maybe the first time a committee meeting?
I got last semester.
Last semester, all right, cool. And at some point, most likely into the beginning of our following semester after this one, so the summer, I want to think about kind of lining up the next one and keep everybody on track, and they will help you stay on track and so forth. So it takes a while to organize that. It's usually a process of up to several weeks to bounce emails back and forth. Again, professors we're highly special individuals, and we can be hard to get all in one room at the same time on the same topic. We're usually happy to do it. It's nice to see our colleagues and hang out and learn about your interesting project, but it does take time because we're all busy running different directions. So give yourself lots and lots of lead time, typically a month or more, to if you want to have a committee meeting, start messaging folks a month or so beforehand to actually get that going. Proposal writing okay? Anybody had a chance to put in some more bullet points in the outline? Not since Tuesday, okay.
I'm feeling like I'm moving from a dead zone finally.
Moving from a dead zone?
Yeah.
Okay.
Slowly, steady forward.
Okay.
Finally.
Right on. That feels good. So what was the transition? Did you start doing work on a different part of it, or?
Basically, I had to struggle because I was thinking how to write this, how to explain that, what I wanted to say, and then I realized one simple thing. The best way to describe my intention start from the fundamentally basics. What is dendrochronology? Description of dendrochronology. Moving forward, how we can apply dendrochronology. What is the expected values of dendrochronology? How dendrochronology can supplement other research methods. And then I'm just didn't notice how nice I finally am writing.
You got some momentum, yeah?
Yeah.
You have some things to say. I mean, of course you have things to say, but sometimes it
Yeah,
takes a minute to
basically,
get
I
there.
just realized that, okay, you know, fancy schmancy stuff, we just focus on fundamentally basic knowledge, which, of course, is not so obvious to some kind of outsider. Because for me, it's, of course, it's so obvious, for you also, because we are foresters. But for example, if some kind of guy from other faculties coming,
yeah,
you should have understanding. And then I started going. Finally, I'm feeling alive again.
Good.
Yeah.
Awesome. And if you recall that everybody's going to have at least one person on their committee outside of your area of expertise,
Actually,
that introduction is pretty useful for them.
That's how I got this inspiration from you.
All right. Good.
Thank you very much.
Good. I'm so inspiring. Wow. No.
Yes, you are.
Okay. Literature review, literature compilation, annotated bibliography, all that sort of cluster of tasks. How's that going? Is anybody feeling kind of overwhelmed with that and sort of sliding to a halt on reading papers? Or is everybody sort of at some hopefully sustainable cadence or tempo or pace of a paper a day, 5 papers a week, but not 1 per day or whatever? Is everybody kind of finding something like that?
I was skiing over the weekend, but yeah.
Okay. Yeah, that's going to happen, right? We're going to get busy with certain things. We have folks out right now at conferences, and that's exciting. It's stressful. It's a huge learning experience, and probably just not in the headspace of reading papers, while you're out at a conference trying to not make a total idiot of yourself or impress people or whatever. That's fine. But the general sense is, over a longer sort of monitoring window over the last 2 weeks or the last month, you're not just loading it all into one horrible day, but chunking it down, spreading it out, and it's something you can do over coffee or Netflix on in the background. Some people prefer to have some background noise. Or you have the imprint of your behind on one of the chairs worn into the wood in one of the study carrels at the library, because you have to have a separate distraction-free space, one of the silent floors of the library, or one of the silent rooms that you can reserve as a grad student to get that work done. So however that looks like for you, give yourself permission to do that. For me, when I have to grind out a project and I need deep thought and focus to do it, I don't go to my office, because we have an open door policy and people are constantly stopping by. Hey, Park, what's going on? Or, hey, I've got this question, or whatever. And it's my joy to help folks with those things, but I can't also do deep work successfully with that. So I go to the library, or I will work from home, or I will not work at home, because my cat and my dog really like to just check in constantly and walk across my keyboard and break the keys. I love that cat so much. But anyway, so give yourself permission to do whatever you need to set up whatever context you need. You can, put your iPhone in a timered lockbox or lock bag, so you're not tempted to look at social media. Whatever you got to do, that's your thing, and nobody else is ever going to know about it, but it will make a difference to you. Okay, cool. All right, so that's good. I'm hearing good stuff. Don't be ashamed or intimidated or whatever to say, hey, Park, I'm really spinning my wheels. I'm struggling to get traction or forward motion on this particular part of the process. Let's bring it up and talk about it. Somebody else is secretly foundering on that too. So we'll all help each other in that way. Okay, cool. That all sounds great. Let's jump back into our discussion of sort of the nature of science and research towards sharpening the pencil on more specific research design principles and stuff like that a little bit later in the semester. So we got all the way into the positivist paradigm on Tuesday. Truth is out there. We can figure out the experiments, given enough time and funding and so forth, to describe reality accurately and successfully and eventually completely. Astrophysics is part of the positivist paradigm. We can map out the universe, and by extending our empirical data collection with new kinds of sensors that are more hyperspectral, we can see further out along either direction on the electromagnetic spectrum. We can sense things like gravity fields and so on and so forth. We can really put together what happened at the beginning of our universe, the Big Bang or whatever it was, and we can deduce these things. So that is a great way. It is a great way to understand reality. But some things don't lend themselves well to the positivist paradigm. So let's take sort of this would be a reduction to absurdity example of taking this beyond its useful or sensible or fair or justified range out to an extreme to sort of show the edge of this. This makes sense to a lot of people, right? The world is what it is. We can run a bunch of experiments and figure out everything from vibrating strings at the bottom end of the scale up to the multiverse and multiple superimposed universes and superposition and stuff like that at the large spatial scale. Some things sort of don't quite work right with that. So let's take the positivist view of religion. So if you wanted to answer a research question about religion, whatever that might be, the positivist or reductionist approach would be to say, okay, well, religion is not like a physical phenomenon. We can't go with a tape measure to it and measure the dimensions of religion. It's more of an abstract concept in maybe the hearts and minds of a particular species. So let's kind of look underneath the concept or the phenomenon of religion. We study phenomena in science and see what we might find if we're not looking at religion, but we're looking at what causes religion or gives rise to, or what we think gives rise to sort of the sensation or impression or phenomenon of religion in humans. So, religion is part of sociology. Religion is a characteristic of humans and history and groups, and sociology is a study of humans in large scale. So, in order to understand religion, let's actually study sociology, and we can bring sociological research tools to bear on answering questions about religion. But sociology, when you really start looking at it and treating it as maybe your subject of research to get at religion, sociology, the study of lots of people, well, really, we could boil that down into psychology, which is the study of the human mind, cognitive processes, development, how we become the human individuals that we are. And then if we multiply up the insights that we get about humans across lots of humans, that's really ultimately sociology. A logical positivist in a reductionist mindset would say. But ultimately, psychology, when you get down to it, it's just a bunch of biochemistry in the brain, and the brain is just part of the biological apparatus of human beings. So when someone is working on psychological studies of hallucinations, for example, which some folks would argue could show up in religion, maybe not, we can trace those hallucinations back to physical phenomena of electrical activity and biochemically mediated reactions inside human brain tissue that are creating those sensory impressions that may not have a real world physical measurable analog that would create those impressions, therefore a hallucination. And ultimately, if we're studying these biochemical reactions inside of brains to try and piece together ultimately something like how does the mind work in an individual, and how do individuals work in groups, and how do groups of people give rise to things like religion, what we're talking about is chemistry. So to understand religion, you got to be a chemist. But I was a chemistry major in college, and I hated it. But it was really interesting. As it turns out, the more chemistry classes you take, you realize it's all just a big lie. You're not doing chemistry at all. It's all physics. It's all subatomic particles. And you just add a bunch of subatomic particles until you've got atoms. And you add atoms together until you've got molecules. And that makes biology. Cells are just molecules, transacting other molecules and signaling other molecules and so forth. So physics, nothing more than math. So to understand God, we have to be good mathematicians. And when you look at advanced math, the notation, the philosophy of the experimental forefront of mathematics looks a lot like religion. We take a lot of math and its fundamentals on faith. So we see that the logical positivist paradigm, used in a reductionist way, we are reducing religion to sociology, to psychology, biology, chemistry, physics, and math. And I'm not obviously being particularly serious about this. This is an absurd example. But this is what you get when you take logical positivism out to its fundamental extreme. Okay? So we need to use other kinds of paradigms or tool sets for kinds of research questions that don't lend themselves well to empiricism, to logical positivism, to pulling out a tape measure and measuring some physical aspect or attribute of a physical phenomenon. Instead, the interpretive paradigm says that things are different and personal and relative across every study subject that you find. So the interpretive paradigm is useful for ecologists, for example, and ethnobotanists. One of the most interesting people I've ever met was a professor of botany who was sponsored by huge evil petroleum companies to go down into the Amazon and talk with shamans and catalog species that nobody had ever cataloged according to the Western science, the botany as we understand it, means or ways of understanding. And he would just listen to shamans for 6 months out of the year in the Amazon and their stories. This little flower, that's a beautiful and interesting flower. I don't think anybody's ever cataloged that before outside of this particular indigenous society. What's the name of this plant in your culture? It doesn't matter what Americans think of as the name of this plant. What is it in your culture? We don't even know that this plant exists. What role does this plant play for you as a shaman trying to work as a spiritual interpreter or as a healer or as a leader or guide in your particular village in this particular culture? You're mentioning to me when I ask about this plant the creation story of your society, of your culture. How does this plant tell you about where you came from? That's a very interpretive way of cataloging a plant. Instead of collecting 1,000 samples of it, drying some of them, blending them up, doing a bunch of biomolecular analysis, drug discovery, stuff like that, right? And there's space for doing stuff like that to find new cancer drugs, for example. But blending up a bunch of plants that we've taken from the Amazon and expatriated to the lab to do all those things, we lose everything that plant means to an entire other culture, okay? So reductionism, that logical positivist paradigm of boiling down one phenomenon into something more fundamental, until you get to math, until it's eating its own tail as a matter of faith. This gives us space to capture anything more than what we can do in a lab, which is a lot, okay? So we're expressing relative values, not absolute truth with a capital T. What does this mean to your people? What does this mean to this particular individual if they're a point of the study? For example, CEOs are commonly studied under the interpretive paradigm. What is special or interesting or different about this particular central or chief executive officer's approach to running this trillion-dollar company, right? Satya Nadella, Tim Cook, Steve Jobs, Elon Musk, Jeff Bezos before he got super weird, and so forth, right? There are a lot of people who are very curious about what is sort of the secret sauce for this particular person, and we can't run lab experiments on that person. We can just attempt to understand their view of reality from their perspective, subjectively. What is their relative sense of things triangulated against other folks, okay? So, this is a little bit unusual or even uncomfortable for some folks in logical positivist disciplines like chemistry or physics or something like that, but some researchers see a lot of value and even ethical obligation in the course of their research, conducting meaningful social action. That is, modifying the phenomenon as you're studying it. As you learn more about it from the inside, affecting change. And that affects other people necessarily. Some folks are really, really not cool with this. It makes them very uncomfortable. And folks who are in this particular space, for example, a lot of people doing sociology research are very active in the civil rights movement here in the United States. So this would be that kind of research, right? learning about socioeconomic status and cultural difference or subcultural differences in downtown Chicago versus Schaumburg, which is a halfway nice suburban, exurban area outside of Chicago, versus the south side of Chicago, which is lower socioeconomic status, and a really pretty different sort of social makeup in that particular set of neighborhoods versus the other two, right? Some folks aren't content to just study it and publish papers on it. They want to see meaningful change because real people's real lives are tied up in that research. And to the extent that the researcher can help with what they see as helpful interventions, that's a thing. Okay? So in this class, we're mostly going to focus on the deductive, logical, positivist thing because most of us are out in some field or forest plot or something like that area looking at objective physical phenomena. And we're cataloging this watershed versus that watershed and so on and so forth. But there's a whole ass other world out there of folks doing other things. And it's all good. It's all valid. There's all, across all of these, essentially the same ethics fundamentally apply. So we'll get into research ethics a little bit later, but we just want to hold some space for a whole other way of doing the interpretive approach. All right. Let's talk about the difference between idiographic versus nomothetic research. So idiographic research is, as you would guess from the morphemes in the first word of the phrase, idio doesn't mean stupid, it means unique. It means special, different, set apart. Okay? So ideograms are symbols used in languages that are each entirely unique and distinct from each other. So ancient Egyptian hieroglyphics would be an idiographic form of language communication. Idiographic research is kind of the same thing. We're looking at a single, unique, inimitable, so cannot be imitated case. A single organism, a single company. If you want to study Apple and what made it a $2 trillion organization, which is bigger than most countries economically in the world, which is weird, but true. Or the state of California, which is like the 10th largest economy in the world, which is weird, but true. Like the state of California, with its fruit and nut groves, has a bigger economy than what, Russia? And Russia's fighting like this big international border battle right now. Yeah. So this is strange. And at some level for some research questions, there's no other case to directly compare it against validly. If you're studying individuals, Steve Jobs, Elon Musk, and so forth, there's no like control condition for Elon Musk. There's not a clone of him that is not an eccentric billionaire that you can be like, well, this one is sort of normal and likes playing pickleball, and this one names his children X or something like that. It's not X, it's like, I don't know, it sounds like a military plane designation like SR-71 or something, I forget what it is. Anyway, right, there's no compare contrast for Elon Musk. So idiographic research is for a single case. We're not running any statistics on this because we can't. A statistic, as defined, is a number that summarizes other numbers. So nomothetic research, we're studying huge sets of much less individual things, and we're generating lots of statistics about those because for every attribute of that thing, we can generate multiple measures or values or numbers. And then we got to summarize all those numbers somehow because our brains can't handle full data sets all at once. Okay? So, idiographic research, we would call these case studies. They tend to be as complete a picture as possible. So somebody writing a book about Vladimir Putin, for example, would seek to spend like a couple of years with Vladimir Putin, getting firsthand impressions, talking with him, seeing how that particular person interacts with other people, leads a country, so on and so forth. Get as much information as possible, dig up every historical archive possible on that particular individual, and then write a really detailed book. What makes this person tick? Why are they the way they are? Here's the whole story. This is everything anybody could possibly find. I found it all, and I wrote this 1,000-page book on this person. It's a very detailed thing. This is not really, in most cases, at all generalizable, because that kind of a complete deep dive for years at a time with a particular individual or single organization like Apple, for example, there's no, goodness gracious, there's no way to anchor it against other organizations, because other people, other organizations, they're divergent from this. There's nothing to build a bridge across with. Okay, there's no way to generalize this and say, all right, so if you do the same daily schedule as Tim Cook, the leader of Apple, then you're going to come to run a $2 trillion organization. It doesn't work like that, right? Obviously. The self-help industry wants to convince you that it does work like that and sell you the guide on how. But a case study can't give you generalizable information. It just gives us insight, detailed insights on that one case. Nomothetic research, on the other hand, is the opposite, right? Causal law governs all of a whole bunch of not completely unique individual organisms or cases or whatever into recognizable patterns. And so we don't want to waste time looking at one in huge detail, because then we're missing out on all of the calibration against all of the others. We don't study one corn plant to death. We study the whole field of thousands of them, tens of thousands, hundreds of thousands, because we want to know, out of that 100,000 corn stalks, which are the top 3% in terms of biomass into the ear. Right? We get bigger ears of corn, more corn to pop, more corn to turn into alcohol additives for our cars because we can't understand thermodynamics, whatever. Okay? So let's grow 50,000 acres worth of corn, tens or hundreds of millions of individual corn plants, and let's study all of them, or let's study a 10% sample of all of them, and find the characteristics or the particular genetic combinations that make this plant 1% more productive into the ear of corn versus all of the plants around it. Okay? And we'll say that genetics, in the case of this example, is the causal law for why this one plant did 1% better than all of the other plants. So if we replicate the gene changes in that particular plant across the next 10 million, now all of the next generation's 10 million are going to be 1% better. So that's a causal law. We can replicate this because once we understand the law, we can use it. We manipulate further generations in that way. Okay? So that's called the covering law model. This is kind of that positivist approach, right? The truth is out there, the capital T. So if we can just figure out with a whole bunch of hypothesis testing what those actual covering laws are. Earlier in the week, we were talking about how we had the bread pudding model of atoms, or matter. And then we have the sort of atomic model, and then the subatomic model, and then the quantum model, and then we've got the superstring model. We're successively uncovering a more correct law and throwing out the old one, saying, that was nice, Taylor Swift, I'm gonna let you finish, but we've got a new, shinier law, and now things are gonna work in our understanding a little bit better. now we can manipulate matter and get new metamaterials, for example. And if the newer, better law correctly explains more, then we have more power. We have the ability to deduce future things that should happen. Okay, so deduction is having a law, a covering law in this case, and guessing if I do X according to this law, I'll get Y. Induction is we did some stuff, we got Y. I think a covering law might be this. So we get to a covering law through induction, building up from data. We start with the law and work down to results and inferences through deduction. Okay. Cool. So we disprove our current factual model. This is why when you take your required one or several statistics classes at the graduate level, the instructor or graduate student teaching that class is going to look you in the face and say, all right, we're not proving anything in science, we're disproving things. We are trying to set up statements, one-sentence statements called hypotheses that we're going to try to break with our experiments. So the language that is specifically used in your thesis results section is based on the results of statistical test XYZ and ANOVA. We reject the null hypothesis that our treatment does nothing. It's this weird sort of double negative thing because we can't prove anything with science. We can't prove anything with science. If there was ever going to be a quiz or an exam for this class, prove things that we thought were good by coming up with something better and designing a test that pits one idea against the other. And the data show us which one is more correct. Okay? So we disprove, we reject null hypotheses in a successful experiment. Careful with that psychology. And science advances one step forward. We have a new, better covering law model. Okay? So we have a theory of gravity until we have to get a theory of relativity that includes gravity and a whole bunch of other stuff and explain some things that our basic sort of Newton apple falling on his head approach to gravity couldn't explain in astrophysics. Relativity sure does. Okay, so relativity also covers things like the speed of light in a vacuum and how the speed of light is the same in different media, and that time elapsed from the perspective of the particle or light wave traveling at light speed. The time between dispatch and arrival is subjectively zero in that space. That doesn't make sense with a current law of gravity before you have relativity. Relativity says, okay, time and space are the same thing. They're just different dimensions of the same thing. Okay, cool. So it takes time. This is an iterative process. This is an iterative process in the case of theories of gravity of centuries. Okay, and that's okay. So it's okay. I need you to hear this for your own sanity and emotional well-being. It's okay if at the end of these 2 years, you haven't replaced your field's equivalent of the theory of gravity. Most of this stuff takes centuries. And yeah, things have accelerated a lot with computing and these days now with AI, so generative research and so on and so forth, in silico research done on a microchip. But this is a lot of work by a lot of people over a lot of years. So don't put on your own shoulders the expectation, the unrealistic expectation that you're going to totally flip the table on your field and blow everybody's mind, okay? Generally, it doesn't work like that. And if it doesn't work like that for you, that doesn't mean you're a failure. It means You are part of the centuries-long lift to get from your current state-of-the-art theory to the next one. Okay, that's a pretty cool thing to be a part of. Cool. All right. So, formatted another way, seeing the exact same thing, really, here is the scientific method. So, this is the nomothetic side of the scientific method, not the idiographic side. The idiographic side is going to be the same thing, running the other way, counterclockwise. All right? So, your research question is the starting point for a deductive study. You read a bunch of previous work that suggests some kind of theory of how things work. And then you read everything you can up until saturation, and it's like, but wait, there's this question that everybody's been dancing around that nobody's answered yet, or nobody's had a chance to run that kind of a study in my area, southern Florida, with a couple of different species or whatever. But it has been done out in California, so we really have this problem in Southern California. Or Southern Florida? What do we do about these particular species and how they're modifying their ecosystem, and the ecosystem is modifying their dynamics and so forth? We have a research question. Even though a bunch of other folks have done previous work, we haven't done everything everywhere for all time yet. So we make an educated guess. We format that educated guess in a pair of statements. If I drain the Everglades completely, there will be no effect on local crane populations. Cranes are a kind of bird. Versus my alternative hypothesis, if I drain the Everglades, a swampy habitat, or a freshwater habitat, we are going to see huge, probably negative effect on crane populations. So we split the Everglades in half, we drain half of it, and we don't drain half of it, and we see how it goes. Monitor the crane populations on both the modified and unmodified section, the experimental treatment section, modified, and the control section, unmodified. And then if we see no changes, then we fail to reject the null hypothesis. This is the specific wording that you're going to see in a lot of these papers where it is nomothetic and using a deductive scientific method. If we do see changes in crane populations, negatively, they all die out locally, or they do better for some reason, unexpectedly, then we reject the null hypothesis that modification will affect. Okay? Is anybody confused yet? This is a lot of double negatives.
Yes.
All right. So your alternative hypothesis is what you think is going to happen. The null hypothesis is, oops, I'm wrong. I'm totally spewing bullshit. I was just hopeful and my experiment didn't work. Okay, that's not actually true. The experiment works if you're able to figure out anything about either hypothesis. You worked. It was successful. It's just maybe not what you expected. All right? There's a real bias towards positive results in science, and that's a problem. So, your hypotheses, you're trying to break them. Trying to prove yourself wrong. So you're wording it negatively so that when I prove this hypothesis wrong, I have proven myself right. So write it up this way and I look really smart. Okay? We'll get more into this if this is confusing later on. Don't worry about it. We set up our methods, right? We pick the site, we detail the species, we put together site maps, we detail the modification that we're going to do on half of the space, 1/3 of the space, or we're going to leave 1/4 of it and try 3 different treatments, or 3 different levels or intensities of the same treatment across 3 of the 4 different strips of the habitat. And this is how we're going to do it. This is the data we're going to collect. And these are the analytical methods we're going to run on the statistics afterwards. We do the field trials, collect those data, work it up, do error checking, and run statistical models on it. and then tell everybody what we did. And that always leaves more things that could have been awesome to do, so that's going to suggest more research questions, and that's one of the last things you say in a publication. Suggestions or directions for future research. We tested X, Y, and Z. In the process of testing X, Y, and Z, it was discovered by one of our field technicians that we also needed to be testing A, B, and C. So a subsequent or follow-on study to this work should take into account A, B, and C as well as the X, Y, and Z that we just tested. Directions for future research. And that's the last part of your results and discussion. Okay, cool. So don't feel like you have to make up anything or make up how to say anything for what you're about to be writing here in your proposal and your eventual results and discussion. All of this stuff is very standard stuff. Just tell us what you're going to do. Tell us what you did. Tell us how you worked on it. And then tell us what you found. Okay? Very straightforward stuff. It can be intimidating the first couple times to figure it out, but you really don't want to be inventing any of this stuff, right? That is not worth your effort. Okay? Cool. So deductive reasoning, put separately, is working from the big established older theory, contextualizing that theory down, saying, okay, but what about this general theory of crane ecology, bird ecology, in this specific context of southern Florida? And then what chunk of the Everglades could we run a little experiment on? So testable on-site application. You're never testing the general theory, the covering law. It's too big. We can't do that. We don't have that much control over all of reality. But we sure can carve out one piece of it. And this other research group at Colorado State University, they're working on this stuff too, but they're going to test out this other thing, or maybe in a mountain habitat versus Southern Illinois' bluff country habitat. Okay? So a bunch of different research groups working together, or sometimes in a friendly competition, very occasionally in an actual antagonistic competition, and you're side-eyeing each other at conferences. It's all very exciting. We're all working on eating different nibbles of the elephant, of the general theory or the covering law. So an example of this from social research, which might be a little bit outside most folks' thing, so hopefully we can see the value in the example here outside of our own areas of expertise. We live in an interesting time of mass media, social media, and state-sponsored media manipulation operations. So social researchers have suggested, as a general idea or covering theory, that we form opinions on groups that we're not otherwise familiar with through what we consume passively on broadcast, internet, whatever media, right? I don't know anything, personally. I don't know a single factoid about a whole bunch of different people groups in Afghanistan, for example. I've never been there. I've only even met a couple of individual Afghani people in my entire life, and I will probably only ever meet a few individual Afghani people in my entire life. And that's not enough of an impression of any entire culture or set of cultures to form any kind of meaningful opinion about them. But gosh, Afghanistan sure has been in the American news, at least, a lot in the past 25 years. So we have a lot of opinions as Americans on Afghani cultures, people, society, the state of the country itself. And so a researcher might suggest that if you take a look and do semantic analysis, where your statistics are being run on the words that people say on TV, quantitative linguistics, USA television tends to cover Muslims in the past 20 or so years, up until a little bit more recently. There's just sort of a negative connotation or even outright bias on certain news venues when talking about Muslims in the United States, abroad, in dominantly or sort of explicitly Muslim countries. And so the more specific testable application, a way we could actually engage with this bigger question is, let's survey a bunch of American teens and see what they think, knowing that most all of them have never been to Afghanistan. Or maybe if we scope it down, let's see how American teens who are not Muslim view other Muslims. Okay, cool. So we collect a bunch of survey results. We eliminate the survey responses, or we hold them separate and analyze those separately, of teens who self-report, I am Muslim. And we would suggest probably that that influences their views of Muslims separately and strongly and independently from the kinds of things that American teens have been hearing about Muslims as sort of their only form of contact. Okay? So you do this study, and maybe you ask the exact same questions in the same way to non-teens in America about their views on Muslims as people. And you draw some, or find some interesting comparisons and contrasts between boomers and Gen Z people and how they think about just a broad swath of human beings. Okay? And some of the things are similar between those two age groups. Some of them are very different. Pretty cool research. Inductive reasoning, again, runs the cycle in the opposite direction. You start with data. You start with observations. And then you work towards a theory of whatever the general theory or covering law might be. So, deductive reasoning is like Sherlock Holmes. You have a theory of how things work, and then you see how the evidence that you collect along the way proves or disproves or modifies that original theory. Here, we don't know what the general theory should be because state-sponsored media manipulation, mass media, and social media, two of the three of those are really pretty new things. So we're not sure how all of this is affecting American teens. So we start with talking with a bunch of teens. We can't give them a survey because a survey is a closed-ended instrument, and we have to have a very clear sense of, it's a deductive style tool. We have to have a very clear sense of the general theory, the covering law first, in order to write those questions correctly, because we're constraining the answers that people can give. But if we just have a whole bunch of interviews, semi-structured, open-ended conversations with American teens and boomers about their views of Muslims as people, well then, we're not real sure what we'll find. We're not real sure where those interviews will go, so they have to be flexible interviews to go wherever they need to. And we start to see that, wow, when we're talking with teens versus with boomers, it's kind of a neutral or even positive conversation with the teens. They either don't care about somebody's, in this case, religious and or ethnic background, or they're kind of even interested in it. Like, it's cool to talk with anybody who's not exactly like you. And the boomers, not so much. So we come to set up at the end of the study a hypothesis, in this case called a contact hypothesis. That is, researchers using an inductive approach found that the more you hang out and talk with Muslims, the more you're kind of okay with Muslims, because they seem to be kind of like everybody else in most respects, right? We all put our pants on one leg at a time, or our body coverings of various ethnic designations, right? So this is a totally opposite way of doing things. You're jumping out of the plane and figuring out how to make your parachute on the way down with inductive research. Except that there's no danger, because the whole point of this is to find whatever you find. Okay? You're not chained to a hypothesis with inductive research. You're setting yourself up to even know enough to set up a hypothesis. So we tend to use inductive research earlier in processes with exploratory research, some new phenomenon. We don't even know what the shape of this thing is, or the size, or the scope, or the complexity of it. Let's just sort of see what we see and start to form ideas about it. And later on, we'll be able to test some of those ideas about how the mechanism of this phenomenon works. Okay, so deductive versus inductive, idiographic versus nomothetic, case study versus large and big sample quantitative research. Okay, qualitative research, where we're just asking questions, versus quantitative research, where we're asking survey questions, and we're mapping every response onto a number and running lots of statistics on those, segmented out by different kinds of survey respondents. Cool. Some pretty big picture ways to go about knowledge generation. Cool stuff. We got to stop right there, but as always, I'm around for questions. So as you're packing up, what kinds of questions do you have? How can I help? Did I poorly explain any of the stuff so far? I invite your questions and comments and verbal abuse. All right. No specific homework assignment for Tuesday. Just keep on keeping on with those outlines and reading sources and catching interesting presentations across campus, whatever looks good to you. Okay? Great. Nope. Do not have to be on campus. It could be a webinar. Ideally, if it's something where you can see the person presenting as well as their content, so that tends to be more of an on-campus thing, like in person, but...
So like a TED Talk, but not a podcast.
Yeah, a TED Talk would be fun, but a podcast, because it's just audio, we're losing so much of that nonverbal communication, you know, posture, expression, stuff like that. You can hear certain aspects of expression, but that's about it. So, yeah, good question. Okay, cool. We'll see you guys and gals on Tuesday. Have a good weekend. Maybe do some studying outside today. Whew. Yeah.
It's so nice.
Finally, right?
It's supposed to